Hello everyone, in this tutorial video I'd like to explain how to show that you can use integrals to find areas between two curves as well as areas between one curve and a straight line that constitutes a horizontal or vertical axis. We do this by first setting two arbitrary functions y equals f of x and y equals g of x, setting both of these functions on the same x points or same interval from a to b, and then we assume in this case that function is greater than g, and we can see if we carefully divide the area between these curves into rectangles and set the width of each rectangle as b minus a over n, like with a normal definite integral, and subtract f of x minus g of x at an arbitrary x point in the interval, which dictates the height of each rectangle, and then you multiply these to find out the area of the rectangle. It follows the total area would be a sum of these areas, and as the sum approaches infinity, you get the actual area between the two curves is the integral of function x minus g of x with respect to change in x. Note that this is just like the normal definite integral. The only difference is that the height is dictated by the difference of functions rather than by one function. If we instead flip it so that the length of each rectangle is given by differences in x equals something of y, and the height is given by the same y and not a difference, it follows by the same exact thought process as above that the total area between these two curves is the integral from y equals c to y equals d of f of y minus g of y with respect to y. Now that we have successfully figured out complex areas of 2D curves, we can figure out complex areas, or volumes more technically, of 3D curves, using techniques from integrals. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.